In our lesson video today, we're going to be talking about the applications of circles, mainly the circle equations. So there's two main formulas we're going to use in this lesson, two main equations. The first one is from the last lesson where we talked about the equations of circles, okay? When we talk about equation of circles, those are always in this form, parentheses x minus h squared plus parentheses y minus k squared equals r squared. Now, remember from last time, h and k are the coordinates of the center of the circle, and r squared is just r, the radius, squared. Now, there's another formula we're going to use in this lesson, and that is the area formula. Okay, so as you look at area, remember that area is pi r squared. And I need you to remember that both of these formulas are recognized, maybe not necessarily remember, but recognize that both of these formulas use r squared. So whatever number is right here for r squared is the same number that we would multiply by pi to get the area. Okay, so that's a connection that's going to make some things easier today. So as we look at our first example, this is the first kind of problem you're going to be faced with, that we've got a local radio station, which is located at the coordinates 5, 2, and it has a broadcasting radius of 140 miles. Okay, so that we don't have to put that on a graph. That would be a really big graph, but it's got this as the coordinates of where that radio station is on some imaginary coordinate plane, and it will reach a radius of 140 miles in any direction. Well, that creates a circle where this is the center of the circle, and then obviously this is your radius, okay? And then it also tells you that your house is located at this point, okay? This is gonna be an x, y that we plug in later on to an equation, okay? But we're not there yet. The first step, part A, is to write the equation that that represents this broadcasting region. So we're gonna just use what the problem gives us, an h and a k for our center, and an r for our radius. So now, while we're writing things up here, kind of making some notes to ourselves, if the radius equals 140, then the radius squared would be 140 squared, or 19,600, okay? So to write the equation representing this, we start off with x minus our x value for h, 5, because remember it's the opposite of whatever the coordinate is, squared, plus y, we would have minus 2 for the k value, squared, equals the radius squared. The radius squared we already calculated is 19,600. Okay? So that is the equation of this circle that we're representing this broadcast region with. So the question for part B, will your house pick up the station, is really asking this, okay? Is the ordered pair, negative 95, 81, less than 140 miles from the center of the circle 5, 2, or the location of the radio station? If it's less than that, then it fits. So here's what we're really doing. We're using this version of that equation, x minus 5 squared plus y minus 2 squared is less than or equal to 19,600. Okay, for any x and y that makes this true, that would be inside that circle. So to answer this question, yes or no, we're going to use this ordered pair as x and y in this equation and see if it actually gives me an inequality less than 19,600 or even equal to maybe. So that's what we're going to do. We're going to plug in our x as negative 95. We still have minus 5 for the h squared. And then y, we're going to use 81 minus 2 squared. And we're going to see, is that actually less than or equal to 19,600? So I put a little question mark there because I don't know if it is yet or not. I have to do the work. So negative 95 minus 5, that's negative 100, not negative 90. So negative 100 squared will give me a positive 10,000. Okay, 81 minus 2, that's 79. And that one I might not know off the top of my head, so let's do that. And 79 squared is 6,241. So when I add those together, I get 16,241, which is less than 19,600. So yes, it's also less than or equal to 19,600. So the answer is yes, your house is located in the broadcast region. Okay. All right. So for number two, we're going to take the same kind of setup because it's a similar idea. We've got, instead of a radio station, we've got a local restaurant where we have these as the coordinates of your center, 1, 2. And it has a delivery radius. So instead of a broadcast radius, it's a delivery radius of 15. Okay, which, by the way, go ahead and say that r squared, if you do 15 squared, that's 225. So that's what I'll use in my formula. And then it also says your house is located at 1011. Again, that's an XY coordinate. We want to see if that's less than 225 when I plug it into that side of my equation. So the first thing we have to do is write an equation. Okay, we're going to do x minus the h coordinate. That's 1. Sorry, 1, not h. We plugged it in. Squared plus y minus our k coordinate, 2 squared, equals r squared, which is 225. So there's the equation that represents this situation. So when you're asked the question, will they deliver to your house? What you're going to do is you're going to take 10 and 11 and you're going to plug in here, and we're going to see if it's less than or equal to 225. Okay, so we're going to plug in, instead of x, we're going to write 10. I still have minus 1, so minus 1 squared. And instead of y, we're going to write 11, and then do minus 2 squared. Do your order of operations, do your parentheses first, 9 squared for 10 minus 1. And then 11 minus 2 is also 9, so there's another 9 squared. 9 squared for each of these is 81. So when I add those together, I get 162, which is less than or equal to 225, okay? So they will deliver to your house. You are less than 15 miles away from that restaurant. So the answer again is yes. Okay? All right, so that's one kind of problem you're going to see in this lesson. Let's go ahead and skip ahead to our next kind of problem. So for these problems, you're given one circle and they actually give you the equation here. Okay, they give you this equation. And then we can use that information to make some changes from this circle to create a new circle. And we're going to work with an equation for that and look at how changing the circle changes the equation. Okay, so first thing I want you to understand before we do anything else, I want you to go ahead and identify what the center is and what the radius is. Okay, so the center here would be the opposite of -4, that's +4, and the opposite of +3 would be -3 for those coordinates. Again, h and k give you the center. And then r, notice that 81 is r squared. So we would do the square root of that and get 9. So that's actually this first bullet point. That's what we're doing. So let me backtrack and explain what we're asked to find here. Circle A has this equation. Circle B, new circle, has an area that is 3 times larger than that of circle A. And no, you can't just multiply everything by 3. There's some tricks to that. It says find the radius of circle B. And then eventually we're going to use that to write the equation of circle B. But first we're going to find the radius of circle B. And no, it's not just 3 times 9. Okay, the radius of circle B is not 27. We can't do things that way. I can explain that in more detail to you later. But for the purposes of this, we're just going to follow these steps. We're going to follow these bullet points. So first you're going to find the radius of circle A by taking the square root of that 81. Okay, so for circle A, we took our r squared equals 81, and then we take the square root of that, because to solve for r, you take the square root of both sides. Okay, so the radius of circle A is 9. Then we're going to use that to find the area of circle A. Okay, area, remember, is pi r squared. Now, I showed you this earlier. Since the equation is equal to r squared, I really don't even need to write it this way. I could just go ahead and say that is 81 pi, because I took pi times 81 and I flipped it around and I wrote it that way. Leaving our answer for an area of a circle written this way is called leaving it in terms of pi. In terms of pi. And that's an exact form of the answer. Now, we are going to go ahead and write the rounded answer of this so that whenever you're entering answers on like the Canvas checkups or the Canvas test, you can just enter decimal answers. So when I do 81 times pi, I get about 254.5. It's 0.469. So we're going to go ahead and call that 254.5. Okay? Let's go ahead and look at that. So like I said, if I do 81 times pi, I get about 254.469, but we just leave it as 254.5 on our paper. Okay, so that's the area of the original circle. So the next part is, it says that this area of circle B is 3 times as large as that. So we are going to triple the area. Okay, 3 times as large as literally means to take our area and multiply by 3. Okay, to find the area of circle B. Okay, we're going to take our area of circle A, 254.5, and we're going to multiply by 3. Now, I'm actually using the original value, 254.4690049. So let me go back to the calculator. If I just take that number and I just hit times 3 in my calculator, it gives me a more exact answer. So doing it that way gives me 763.4. If you just do 254.5 times 3, you get 763.5. I'm not going to be picky about that one decimal value. Okay, but I also want to show you this using the in terms of pi. So if I take that in terms of pi version of the answer, 81 pi, and I multiply that by 3, I get 243 pi. Now, if you aren't sure about this, if I plug that in the calculator, 243 times pi, I get the exact same thing, 763.4. Okay, so this is equivalent to that decimal. So that's my new area of circle B. Then we can use that to find the radius of circle B by using the area formula and solving for r. So again, the area formula is pi r squared. So I'm going to plug in the area I found for that. Well, 763.4, if I plug that in for A, first thing I would do here is divide by pi, right? When I do that in my calculator, I do 763.4 divided by pi in the calculator, I get r squared is something that rounds to 243, which makes sense because let's say instead of 763.4, instead of using that form of the area, if I used this form of the area, 243 pi, and I divide it by pi, pi's cancel, r squared is 243. Now we do want to go ahead and solve for r. They want the actual radius of circle B. So I'm going to take the square root of that, and I would get about 15.6. Okay, so that's my radius of circle B. I'll even fill in that blank, 15.6. So to recap what we found, the area of circle A at first was 254.5. The area of circle B when you multiply by 3 is 763.5 or 0.4. Okay, depending on how you round. And so that helps me find the radius of circle B now. Now, the next part of that is I'm going to use that new radius to write the equation of circle B, assuming that circle B shares a center, meaning I'm not changing the center. If I'm not changing the center, this entire side of the equation does not change. So I'm going to keep that x minus 4, y plus 3 squared. So circle B still starts with that, x minus 4 squared plus y plus 3 squared. The only thing that's different is it's equal to a new r squared, okay? So the new radius, if I squared both sides of that to get r squared, guess what? You're going back to getting 243. So this should be equal to 243, okay? If the square root of 243 gave me the 15.6, when I turn around and square that, I'm back to 243. So that's the equation of circle B that has an area 3 times as much as circle A. All right, one more part of this though. Now we're going to say that circle B, which is this equation, for part C here, we're going to say that it's moved, we're going to move that 3 units right and 5 units up. So if I'm moving something to the right, here's what that changes. That changes the x values, okay? The x values at the center change by going left. In that case, we would subtract, or right. In that case, we would add. Remember, we add to go right on the x-axis, we subtract to go left. So that's why that works that way. And the y values of the center change by going down or up. So down would be subtraction, and up would be addition. Okay? So what we're going to do is we're going to take the original coordinates of the center, HK, and we're going to apply these changes, right 3, up 5. So we're going to take that h value, and if I'm going to the right 3, that means I'm going to add 3, okay, to get a new h value. I'm going to take my k value of the center, the y value of the center, and since I'm going up 5, I'm going to add 5. Well, then I just plug in the numbers that I have for my equation. Okay, my original h was 4. My original k was -3, coming directly from this. So we're going to take 4 and we're going to add 3 to it. And we're going to take -3 and we're going to add 5 to it to get a new center now. So the new center, 4 plus 3 is 7, and -3 plus 5 is 2. So the new center is the coordinates 7, 2. Then I just take them and I plug back into my circle equation. So instead of x minus 4, it's x minus 7 squared. And instead of y plus 3, now it's y minus 2 squared. This is still equal to 243. From going from part B to part C, I didn't change the radius this time. I left it the same radius, I just moved the center. So r squared is still 243. Okay? So as you're looking at these bold statements are kind of your guide to do this. So what we're going to do, there's one more example here. But this is a very similar problem to what we just did. So what I want you to do, I want you to pause the video and try and do this one on your own. If you need to go back and look at that example, go ahead. But try and do this completely on your own, parts A, B, and C. If you get stuck, feel free to just watch ahead in the video and see the explanation. But try and do this one on your own. All right, if you've had enough time, you should be ready to check this answer. If not, keep it paused. And otherwise, these are the answers you should get. Okay, for part A, we start with our original equation here. So notice that r squared equals 49. So we start by finding the area of circle A. Area is pi r squared. R squared is 49, so we just do 49 times pi, which is about 153.9. Then we move to find the area of circle B because it says the area of circle B is 4 times larger than that of circle A. So we do 49 pi times 4 and get 196 pi, or we take our decimal value times 4 and we get about 615.8. You might have gotten 615.6 if you rounded differently. I think that's the other answer you could get. And then we need to find the radius of circle B. Well, again, the new area is 196 pi. Area equals pi r squared. So 196 pi in place of the area equals pi r squared. The pi's cancel. So r squared is 196, and the square root of that is 14. Okay? So for part B, it says to write the equation of circle B, assuming the center hasn't changed. They share a center with circle A. So this side of your equation stays exactly the same as it was printed in the original part of the problem. The only thing that's different is instead of r squared being 49, r squared is 196 because the radius 14 squared is 196. Okay. Finally, part C, this time we're moving to the left and down. So we're actually going to subtract 5 and subtract 2 from H and K. So the original center coordinates of 7, 4, from 7 we do -5, and from 4 we do -2. That moves it to the left 5 and down 2. And we get a new center of 2, 2, and I plug those in and I get my new equation for circle B after it moves is x minus 2 squared plus y minus 2 squared equals 196. Okay, I've got one more thing to show you here, okay? In Canvas, when we enter these kinds of answers in our Canvas checkups, like our homework checkups, or when it comes time for the test, we've actually created a format to where you can enter the equation of a circle using these fill in the blanks. So you'll notice I've got my blank here of parentheses, then a blank squared, plus parentheses and another blank squared equals that other blank. So let's say I wanted to enter this equation, okay? Let's say I wanted to enter this equation, x minus 2 squared plus y minus 2 squared equals 196. Well, that means in my first blank is the x minus 2 part. Try and make sure you go lowercase x. If you do capitals, it usually accepts that, but sometimes it doesn't. So go lowercase x minus 2. All right, then for the other one, go to the other, type your answer here. And that one was y minus 2. So we would enter y minus 2 in that parentheses. You don't need to enter the parentheses yourself. Y minus 2, just like that. And then it equals 196. So in that blank, we would just type in 196, like that. Okay, and so you would make it look like that and hit submit, and it would tell you if you're right or wrong after the quiz is done grading. All right, so that's how you enter equations of circles using this format we've created in Canvas quizzes.